In the space of science and monstrous secrets, the subject of what existed before the massive blast has sparked mixed discussions and charmed characters for a surprisingly long time. This tremendous question doesn't simply test how we interpret the universe. It challenges the very limits of human knowledge. Imagine standing at the edge of existence, gazing into the vast shadows, and contemplating what lay there before our universe was conceived. The event of the Big Bang marked the dawn of humankind, space, and all that we know. But was there a moment before this? Could there have been a state of nothingness, a silence before the cosmic symphony began? And if this is true, was it truly empty? Or perhaps something even more profound and disturbing existed before time itself? As we delve deeper into this question, science takes us on a journey beyond the universe's starting point, into ideas that challenge our understanding. Physicist Brian Cox, known for his insights into the wonders of the universe, suggests that something astonishing could have existed before the Big Bang. He invites us to reconsider our notions of reality and existence. In this exploration, we'll analyze the science, the theories, and the remarkable secrets that could explain what existed prior to everything. We'll examine ideas like cosmic inflation, quantum fluctuations, dark energy, and even multiverses. The answers may leave you astonished, but they could also unlock new understandings of our place in the universe. Prepare to dive deep into a world beyond imagination, a world where science still bends under the weight of the unknown. Shadows stretch into the unexplored, leaving scientists awed and sometimes unsettled. Let's uncover what may have existed before the Big Bang and why these theories challenge everything we thought we knew. To appreciate what might have existed before the Big Bang, we first need to carefully consider what the Big Bang truly was. The Big Bang, as scientists define it, refers to the moment when the universe became incredibly hot and dense, expanding rapidly to trigger the formation of all matter, energy, and forces. When we look at the night sky, we see evidence of this hot origin, with galaxies spreading out from a primordial starting point. But why did this happen? And was there a time before this dense, hot beginning? According to the theory of cosmic inflation, there was indeed a before, and it was far from empty or tranquil. Cosmic inflation suggests that before the Big Bang, the universe was in a state that was cold, empty, and free, essentially like a massive vacuum. However, this vacuum wasn't entirely empty. It contained a tremendous amount of energy that fueled the rapid expansion of space itself. This expansion, called inflation, happened so quickly that it effectively set the stage for everything that followed. In a fraction of a second, space expanded at unimaginable rates until the inflation slowed down and the energy transformed into matter, particles, and the forces we observe in the universe. But what was the nature of this energy? Why did it suddenly expand the universe, and why did it stop? Scientists believe that this boundless expansion created regions of the universe, each experiencing its own Big Bang. Imagine a fabric stretching infinitely with tiny bubbles forming here and there, each bubble representing a universe, including our own. This idea, called the inflationary multiverse, suggests that there are potentially countless Big Bangs and an infinite number of universes. Our own is just one of many. This grand, mind-bending reality challenges our understanding of the universe itself and leaves us with a question: what else is out there? The idea of nothingness before the Big Bang is speculative, not definitive. Yet, based on our current understanding, even if you strip away all energy, particles, and radiation from the universe, it would still not be truly empty. Our universe is filled with dark matter, dark energy, quantum fields, and other forces that weave an intricate tapestry of something, even in its most barren state. Even if we imagine removing these forces, leaving only a void, the universe would still generate new kinds of energy. This fact alone is perplexing to scientists, as it suggests that true nothingness might be impossible within our infinite reality. Space itself has properties, rules, and constants that prevent it from being completely empty. For instance, there's a phenomenon called zero-point energy, which represents the lowest possible energy state of quantum fields. In this state, particles can still momentarily appear and disappear, creating an eerie ripple of activity even in what should be an empty void. This challenges our concept of a true vacuum and suggests that, yes, even before the Big Bang there was something that scientists are only beginning to comprehend. One of the most astonishing theories in modern cosmology is the possibility of eternal inflation. If inflation could create our universe, it's possible it could go on forever. Brian Cox describes an extraordinarily vast inflationary multiverse where universes are endlessly created and keep expanding. Imagine each Big Bang as a spark igniting another universe, while inflation continues in other regions, creating countless other universes. This process could, in theory, go on forever. This idea of infinite universes gives rise to the concept of a fractal universe, where each new universe might create its own Big Bang. Each universe exists as a separate, independent space, unaffected by the others due to the rapid expansion of space. For scientists, this theory is both exhilarating and unsettling, as it suggests an endless multiverse with no definitive beginning or end. Imagine our universe as just one tiny part of a giant cosmic structure, endlessly expanding and constantly creating new universes. And what if the unsettling truth is that there is no before or after, but rather a timeless pattern of universes forming and dissolving? Our understanding of nothingness changes when we consider quantum field theory. According to this theory, the universe is not a collection of matter floating in space. Rather, it is a complex network of energy fields that fill the universe, interacting to create everything we observe. These fields are like invisible oceans, with particles acting as waves or disturbances. Even when fields are at their lowest energy level, known as the vacuum state, they are still active. Particles can appear and vanish in these fields momentarily, borrowing energy before returning it. This phenomenon results in virtual particles, entities that briefly exist and then disappear, leaving only a faint memory of their presence. The concept of virtual particles challenges the idea of a true void. Even in an empty universe devoid of all matter, radiation, and energy, quantum fields would remain active, sometimes creating fleeting particles. This constant activity, in what should be nothing, suggests that the universe doesn't acknowledge our concept of absolute emptiness. Vacancy, the fields and powers persevere through, filling the universe with a secret energy that forestalls outright nothingness. This figuring out brings up a captivating issue. On the off chance that fields make particles and particles make matter, might the actual universe at some point have risen up out of this nothingness loaded up with quantum fields? Dark energy is a strange power that, as of now, drives the accelerated expansion of our universe. But did dark energy exist before the Big Bang? According to certain perspectives, the fact that dark energy exists today is an artifact of an energy field from before our universe's development. The properties of dark energy seem to suggest a massive, mysterious power that could have existed in a form preceding the Big Bang. Some theories suggest that dark energy, in a much stronger state, might have powered the inflationary stage, causing rapid expansion. The presence of dark energy suggests that, even if our universe were depleted of all matter and radiation, this power would continue to expand the fabric of spacetime. This idea leads to a profound question. If dark energy was present before the Big Bang, might it have formed the conditions that led to the birth of our universe? Could dark energy be the silent architect of inflation, or even the true origin of our universe? As we explore this possibility, we face the potential of dark energy as not just a force shaping our universe but as a key that could unlock the secrets of the multiverse itself. Cyclic cosmology. Another theory that offers an alternative to the Big Bang as the ultimate beginning is cyclic cosmology. The idea that the universe goes through vast cycles of birth, death, and rebirth. In this model, the Big Bang is not a one-time event but part of an eternal rhythm where universes expand, collapse, and then regenerate in a new cycle. This theory suggests that our universe could have been reborn from the remnants of a previous universe. The process of contraction and expansion in a cyclic pattern would mean there was never a true beginning, but rather an eternal series of universes arising, evolving, and renewing themselves over and over again. Cyclic cosmology raises significant questions about time, as it suggests that time itself might be cyclical rather than linear. If this theory is correct, it could imply that what existed before the Big Bang was simply another version of the universe, one that collapsed only to give birth to our current universe. For researchers, this theory offers a rich response to the question of ultimate origins, proposing that there is no true beginning. The universe has always existed in some form, transcending our notions of time and existence. Gravitational waves and early universes. Early-stage gravitational waves are another intriguing concept that could hold clues to what existed before the Big Bang. Gravitational waves, ripples in spacetime caused by massive cosmic events, could provide insights into the universe's earliest moments. If early-stage waves are ever detected, they could serve as echoes of what preceded the Big Bang. The discovery of such waves would be a groundbreaking advancement in our understanding of the universe. These ripples in the fabric of spacetime could reveal the past states of the cosmos, potentially giving evidence of what existed before the Big Bang. Theories beyond the Big Bang. 1. The no-boundary condition. Proposed by physicist Stephen Hawking and others, this theory suggests that the universe does not have a traditional beginning as we understand it. Instead, the universe could resemble the surface of a sphere, with no edges or boundaries. According to this idea, the universe's beginning is an illusion created by the flow of time, which might curve back on itself. 2. Quantum foam. On the smallest scale, quantum mechanics suggests that empty space is not truly empty. Quantum fluctuations occur, creating particles that pop in and out of existence. This quantum foam could have preceded the structured universe we observe today. The Big Bang might have been the moment when this foam transitioned into the smooth spacetime we now experience. 3. The cosmic egg. A philosophical framework envisions a pre-universe existing in a collapsed state, sometimes referred to as the cosmic egg. This singularity could have contained all the mass, energy, and information that would eventually create our universe. The universe might undergo cycles of expansion and contraction, with our current universe being just the latest iteration. 4. The multiverse hypothesis. This theory posits the existence of countless parallel universes, each with its own set of physical laws. The Big Bang of our universe could have been one event among many, giving rise to a vast multiverse. 5. The holographic principle. This fascinating idea suggests that all the information in our universe could be encoded on a two-dimensional surface, much like a hologram. Our three-dimensional perception of the universe might be an illusion, and the universe's origins could lie in a simpler, lower-dimensional structure. 6. String theory. String theory proposes that the fundamental building blocks of the universe are not particles but tiny, vibrating strings. These strings could give rise to matter, forces, and even higher dimensions. The Big Bang might have been the result of interactions between these higher-dimensional structures. Conclusion. These theories, from quantum mechanics to cosmology and beyond, offer dramatically different perspectives on the origins of the universe. While we may not yet have the tools to answer definitively what existed before the Big Bang, each new hypothesis brings us closer to understanding the nature of our reality and the ultimate beginnings of existence.